Hi, this video is designed to teach you about how to solve a one-step equation and how to check your solutions to make sure you got that right. Here we go. An equation. An equation is a mathematical sentence containing an equal sign, showing two equivalent values or expressions. When we talked about expressions earlier, we realized that expressions were phrases. They weren't complete thoughts. But an equation is actually like a sentence. It's the full thought. And it shows one side being equivalent to the other. Inverse operations is also something you're going to need to know a lot about. Inverse operations are opposite operations that sort of undo each other. So for example, addition and subtraction, right? If we add something to something, to get back to what we started with, we would just subtract it back out. And multiplication and division are the other set of inverse operations. To undo multiplication, you divide. And to undo division, you multiply. Start with 2, for example, and add 8. I want to know, how would I get back to 2? So look at this. If I have 2, that was my original grid, and I added 8 to it, I now have 10. But if I want to get back to the 2 I started with, I'd have to take the 8 away. And then you can see that that 10 will turn back into a 2. It's just a visual expression of what inverse operations look like. So again, if I started with a 2 and I added 8, to get back to the original 2 I had, I have to subtract 8. Properties of equality. If you add, subtract, multiply, or divide a number from both sides of an equation, the two sides remain equal. So if I'm adding 2 to one side of an equation, I add 2 to the other side, the equation is still going to be equal. It's like a bunch of scales. We're balancing them out to make sure that they stay equal. Now let's get into the meat of this video. We're going to talk about solving equations. So first let's talk about the basics. This is an equation. X plus 2 equals 6. What it says is that whatever x plus 2 is, it needs to equal 6. When solving equations, you are looking for the value of the variable that will make the equation true. So we're looking for what value would make this equation true. That means we're looking for what's the value of x that will make this equation true. So what value of x could we put in there where we're going to get a 6 on both sides? Ask yourself, what plus 2 equals 6? Well, I hope you said 4. 4 will be the answer to this equation. It will be the solution, because 4 plus 2 equals 6. That makes this sentence true. Or you can ask yourself, what is happening to the variable and how do I undo it? And this is going to be our focus for solving equations, because not all equations are this simple, right? It's not always easy to identify what the value of the variable is on your own. But if we ask ourselves, what's happening to the variable? So in this case, the variable x is being added by 2. How do I undo addition? What was its inverse operation? Subtraction. So if I subtract 2 there, that's going to undo what happened to our variable. Whatever I do on one side of an equation, I have to do to the other side to keep it balanced. So we have to subtract 2 from the other side. Well, the left side of the equation is going to turn into just plain old x. And 6 minus 2 is 4. Remember, if we had x and we added 2, and then we took those 2 back away, we're back to x where we started. X equals 4 is the solution to the equation. Now let's take a look at what this looks like with a model. Okay? X plus 2 equals 6. Here's that cup. That represents our x. Plus 2 more. And that equals a grand total of 6. Now let's go back to the left side and look at how this looks algebraically. We know we've added 2 to x, and you can see that the cup representing x has been added by 2. To undo adding by 2, we use an inverse operation. That would be subtracting by 2. And they're gone. But to keep this equation equal or balanced, we need to make sure we do the same thing on the right side of the equation. And if you notice, that will leave us with a value of 4. So x will equal 4. The number of things in the cup would be 4. Now let's check our solution. So we've done all the work on the left-hand side. And I've just rewritten the equation so that we can check it. If we got the right answer, when we substitute it back in for the value of the variable, we should find that we get the same number on both sides of our equation. So let's take a look. First step we're going to use is substitution. So instead of x, now I'm going to replace that with 4. Then I'm actually going to do the work. I'm going to check it. What is 4 plus 2? It equals 6. Since 6 is on the left and 6 is on the right, we know we got the answer correct. The great thing about this unit and about this particular skill is you can check all your work before you even give it to your teacher. All right, here's another example. X plus 3 equals 8. So the first thing we're going to ask ourselves is what's happening to the variable? It's being added by 3. How do we undo addition? We use the inverse operation, which is subtraction. And whatever I do to one side of an equation, I have to do to the other to keep it balanced. And then we do the math. That was the inverse operation step. When I do the math, I'm going to get that x equals 5. Remember, if we started with x, we added 3 and then took those 3 away, we're back to the x that we started with. And 8 minus 3 equals 5. That's your solution. Now let's check the answer. So here's the original equation. We are going to substitute in for the 5 where x was, because that was what we think our solution is. Now I say think because we're checking it right now to verify. Then we'll check it by adding. What is 5 plus 3? It's 8. And since 8 is equal to 8, it's a true statement, we know we've gotten it correct. Here's another example. X minus 2 equals 3. What's happening to our variable? Well, it's being subtracted by 2. How do I undo subtraction? I use its inverse operation, which is addition. So we're going to add 2 on the left, and whatever I do on the left side of an equation, I have to do on the right to keep it balanced. When I do that, that's the inverse operation step. Then, if I have x, I take 2 away, and then I add the 2 back. I'm back to where I started. And 3 plus 2 is 5. So our solution is x equals 5. Now we're going to go check to make sure that that solution actually works. So we start with our original equation. We substitute. We decided that x equals 5 is our solution. So we're going to replace the x with a 5. And we're going to actually do the check. What is 5 minus 2? Well, it's 3. Since we get the same thing on both sides of our equation, we know we got a correct answer. How about this example? This is 2 times x equals 10. Remember that if you see a coefficient and a variable side by side and no operation is indicated, we understand that that means multiplication. So what's happening to our variable? It's being multiplied. How do I undo multiplication? I use the inverse operation, which is division. Now I'm going to show division using the fraction symbol here. You can use the division sign as well. This is typically what you'll see. Remember that the fraction bar actually represents division. Whatever I do on the left, I have to do on the right to keep it balanced. Well, those 2's are going to divide out, leaving me with just, that's your inverse operation step. Let me not jump ahead. And the 2's will divide out, leaving me with just an x, right? Because 2 divided by 2 is 1. And 1 times x is x. And 10 divided by 2 is 5. That's our solution. Now we got to check our answer. So in place of x, we're going to substitute in a 5. And 2 times 5 should equal 10 if we did it right. We're going to check it. 2 times 5 is 10. Since we get the same answer on both sides, we know we're correct. All right, one more example. This expression, or this equation, is x divided by 3 equals 7. So the first thing we need to do here, and by the way, remember that that fraction bar represents division. That's why this is x divided by 3 equals 7. We're looking for the number that can be divided by 3 that equals 7. So first we have to identify what's happening to this variable. Well, it's being divided. What's the inverse operation of division? That would be multiplication. So we'll multiply by 3 on both sides. And notice that I used parentheses here. Remember that we don't have to use an X or a dot. There's lots of different ways to represent multiplication. One of them is by putting parentheses around a number, indicating that we're going to multiply. When we do that, that is the inverse operation step. And then we find that the left side becomes x because we've undone what happened to it. And 7 times 3 is 21. That's our solution. Now we want to check our answer. So we start with the original equation. We substitute 21 in where x was. Then we do the math, and 21 divided by 3 is 7. Since we get 7 on both sides, we know we've gotten it correct. I want to point out here that every time you solve an equation, we'll be looking for the inverse operation step, the solution, the substitution, and your final check. Don't forget that final check and actually do the math. A lot of kids will put in the answer twice because that's what they think we're looking for. But the purpose of the check is to make sure that the math that you do actually matches up. All right, now you guys try. Here's an equation. Remember, you can pause the video at any time, do the problem, and come back to see how you did. So, first thing we're going to ask ourselves is, what's happening to the variable? Well, in this case, it's being added by 2. What is the inverse operation of addition? That would be subtraction. We're going to subtract on both sides to keep the equation balanced and equal. When I do that, that's the inverse operation step. Then we'll actually do the math. So we end up with x equaling 3 because 5 minus 2 is 3. That is our solution. Don't forget to go check your answers to make sure you're correct. If I take the original equation and I substitute in 3 where x is, I should get the same thing on both sides. Well, 3 plus 2 does in fact equal 5. So I know I'm good to go. All right, how about this one? X minus 7 equals 4. First, we ask ourselves, what's happening to the variable? Well, it's being subtracted by 7. So we're going to use its inverse operation, which would be addition. And whatever I do to one side of an equation, I always do to the other to make sure that it stays balanced. That's the inverse operation step. When we actually do the math, we get that x will equal 11. That is our solution. And we always want to check our answers to make sure we're correct. So we take the original equation and we substitute in the value 11 where x is. If I take 11 and I subtract 7, I find that I get 4 on both sides of the equation, so I know I've got a good solution. How about this one? 3x equals 15. First, we start with figuring out what's happening to our variable. It's being multiplied. The inverse operation of multiplication is division, and again, we're going to use that fraction bar to indicate division. Whatever I do to one side of an equation, I always have to do the other to keep it balanced. And that's the inverse operation step. Then we find that x equals 5. That is our solution. To check to make sure that we got it correct, we plug in or we substitute the value of 5 for the variable x. And when I do the math, 3 times 5 does in fact equal 15. Since I got 15 on both sides, I know I'm good to go. All right, try this last problem. X divided by 8 equals 9. We know it's division because, again, the fraction bar represents division. So what's happening to x? It's being divided by 8. To undo the division, we're going to multiply by 8. And whatever I do to one side of an equation, I have to do to the other. So our final answer, that's our inverse operation step. So our final answer will be x equals 72. That is our solution. Now to check that, and don't forget that's a very important step and a requirement for this unit. We're going to replace or substitute in 72 where x was. Then we're going to do the math, and 72 divided by 8 actually equals 9. Since I got 9 on both sides, I know I'm good to go. All right, here's a quick summary of some of the things we've learned today. An equation is a mathematical sentence, a complete thought, containing an equal sign, showing 2 equivalent values or expressions. Inverse operations are opposite operations that undo each other. For example, adding and subtracting, or multiplying and dividing. When solving an equation, you're looking for the value of the variable that makes the equation true. That's what the solution is. And in most cases, especially right now, there's only one and only one answer that will make an equation true. If you add, subtract, multiply, or divide a number from both sides of an equation, the two sides remain equal. So whatever I do to one side, I have to do to the other, and it will keep them equal. Steps to solving equations. This is super important. Don't forget, we start with inverse operations, we get a solution, we substitute that solution in, and then we check our answers. Hope you guys got a lot out of this video. Make sure you practice a ton because equations is one of those topics that you are going to be using for the rest of your mathematical career. So knowing how to solve them is really important.